Mark Twain, the Steamboat, and the Mississippi Mystery. A question that stumps most students. Mark Twain once traveled down the Mississippi River by steamboat in 5 days. On his return journey upstream, the same trip took 7 days. Now let's ask two intriguing questions. How many days would the same trip take if there were no river current? How many days would a one-way trip downstream take if traveling by raft? Most people make the same mistake when answering the first question. They assume that the current's effect cancels out if you simply take the average of 5 and 7 days, arriving at a 6-day estimate. But the actual answer is slightly less than 6 days. Why? Let's break it down. Step 1. Understanding the motion of the steamboat. We assume that the steamboat's speed in still water is s, and the river current speed is c. Since speed and currents are additive, the steamboat's effective speed, downstream with the current, is s plus c, upstream against the current is s minus c. Let d be the one-way distance of the trip. Using the distance formula, distance equals rate times time. We write two equations, one for the downstream journey, d equals s plus c times 5, 2 for the upstream journey, d equals s minus c times 7. Now we need to eliminate c to solve for s. Step 2, eliminating the river current. To cancel out c, we multiply the first equation by 7 and the second equation by 5, so they both have the same coefficients. 7d equals 35s plus c. 5d equals 35s minus c. Adding both equations together, 7d plus 5d equals 35s plus 35c plus 35s minus 35c. 12d equals 70s. S equals 12d divided by 70. Since we want to find how long the journey would take without the current, the time in still water would be t equals d divided by s. Substituting s equals 12d divided by 70, t equals d divided by 12d over 70. The d's cancel out, leaving t equals 70 over 12, approximately 5.83 days, so the correct answer is 5.83 days, slightly less than 6 days. Step 3, how long would a raft take? Now let's answer the second question. How many days would a one-way trip take downstream by raft? A raft has no engine, meaning its own speed is 0. It moves only with the river current, so its speed is simply c. Using our formula, d equals c times t. Solving for tt equals d divided by c. To find c, we subtract our two main equations. 7d minus 5d equals 35s plus 35c minus 35s minus 35c. 2d equals 70c, c equals d divided by 35. Substituting this into t equals d divided by c, t equals d divided by d over 35. Again, the d's cancel out, leaving t equals 35 days. So a raft floating downstream with the current would take 35 days to complete the trip. Bonus trick question. What about going upstream by raft? If a raft is floating without an engine, it cannot move upstream against the current at all. The answer is infinity. The raft would never reach its destination. Final thoughts. Most people assume the time in still water is simply the average of 5 and 7 days, but it's actually slightly less than 6 days. Meanwhile, a raft floating downstream would take 35 days, much longer than the steamboat, and if you tried to raft upstream, well, you'd be stuck in the same spot forever. So next time you hear a simple math puzzle, think twice before averaging the numbers. See you next time for another Mind Your Decisions mystery, solving the world's toughest problems one question at a time.